In this video, we'll be going over a GCSE style question that's aimed at the higher grades. And this question is a non-calculator question. So this will be coming in your paper ones where you don't use your calculator. And so this is about arcs, sectors, and circles. The diagram shows a square ABCD with sides of length 20 centimeters. It also shows a semicircle and an arc of a circle. AB is the diameter of the semicircle, and AC is an arc of a circle with center B. Show that area of the shaded region over the area of the square is equal to pi over 8. So to find the area of our shaded region, we're going to have to find the area of our sector, and we're going to subtract the area of our semicircle. To find the area of a sector, we know that in a square, every angle is 90 degrees. And 90 degrees is 1/4 of 360 degrees, and that's the angle around the point. So from that information that we have, our 90 degrees of angle ABC, we can immediately identify that the sector that we have with the arc of the sector that has the radius of AC, that has the radius of AB, is already 1/4 of the full circle that AC is an arc of. So the area of our arc here is equal to 1/4. So ACB is equal to 1/4, and then we have the area of our circle, which is pi r squared. So times pi times r squared, and r here is 20. So we have 1/4 times pi times 20 squared, and this simplifies down to, so 20 squared we know is 400, and so 1/4 times 400 is 100, and we just have 100 pi. Now the beauty of this is, because it's a non-calculator paper, and it's a show that question, we can just keep pi as it is. We don't have to multiply 100 by 3.14 or anything like that. And an added benefit of a show that question is that it shows what your answer should look like at the end. It shows you what your endpoint is. So we know that the area of our arc here is 100 pi centimeters squared. Now to find the area of our shaded region, we have to now subtract the area of the semicircle. So we find our area of our semicircle AB. And the semicircle is half of a circle. So we have this as half times. So the area of our semicircle here is equal to half times pi times, and we're given our diameter here as 20 centimeters. Make sure you take note of this point, because you may accidentally put your diameter where your radius is meant to be. So we know our diameter is 20, so our radius is 10 centimeters. So we take 10 here, so this is times 10 squared. When we simplify it down, this gives us, so 10 squared is 100, and a half times 100 is 50. So we're left with this equaling 50 pi. Now, the area of the shaded area is going to be the area of our arc minus the area of our semicircle. And we've given it in terms of pi, so it should be a nice, easy subtraction that we have to do. So this is equal to 100 pi minus 50 pi, and this is equal to 50 pi. Now this is the area of our shaded region. Now we've got that, we have to now find the area of the square, because that's the denominator in the fraction they have given. So we know that the side length of our square is 20 centimeters. So this can just be, this is equal to a squared, where a is our side, and so our side here is 20, so it's 20 squared, which is equal to 400 centimeters squared. And now we put it into our fraction. Area of the shaded region over area of the square. And so for the show that question, you have to make sure that you label everything that you're working out, because these questions, they will give a lot of marks for showing you're working out, as to show that you haven't worked backwards or you haven't guessed the values. So we'll now put it into our fraction format. So we have 50 pi over 400. And now we can simplify this just by simple cancelling out. We know that 50 times 8 is 400. So in our numerator, we'll just have pi, and our denominator will have 8. And you have to show this cancelling out here. You have to show that you've got your original fraction and how it's equivalent to your pi over 8.
As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.